All right, we're going to check out graphing and writing compound inequalities. And you can see here that we have two different types, an and, or, and or. A compound inequality is just literally two inequalities joined by those words. And in fact, this is what an and usually looks like right here, is it is between two dots on an inequality, and an or often looks like kind of a separation. And I know that might seem a little bit in the air, like what the heck is he talking about? We'll get into it right now. So here we go. An and is going to be the intersection, and that's this part. Think of an intersection, think of an overlap, and it's going to show the solutions of both inequalities. And not just one of them. So what I mean by that is if we look here, x is greater than or equal to 2. Okay, here's the greater than or equal to part, and then it shades this direction, right? And then what if we have this other one, x is less than 5? So an open dot here, and then shade this direction. Well, notice how we have a solution going to the left, we have a solution going to the right. So when we say and, they actually overlap, and it's this piece and this piece, and that's why it's shaded here. I like to think of it as if I ask for a peanut butter and jelly sandwich, I'm looking for both peanut butter and I'm looking for jelly. That just is peanut and jelly, but you know what I'm talking about. So right here is how they can be written. They can literally be written with the word and. But what might show up, I don't want to say more often, is where they're combined like this. And this is where I think that it really kind of gels with the graph, is it really looks like x is between 2 and 5, and that's what this says, right? Okay, so let's check on an or. An or is the union of the graphs of inequalities. And when I think of a union, it's like two people getting married, there's a union, whatever. It's basically going to be both answers. And actually, they say either answer right here. So let's dive into that. Y is less than or equal to negative 2. So there's less than or equal to. There's the negative 2 part, right? Y is greater than 1. So here's the open dot and the shading to the right for the greater than 1. Notice down here, it's got or, and it just has both of them written. And it takes this part, and it puts it on the final answer. It takes this part, and it puts it on the final answer. Both of them, both, either. It's the union. And then kind of notice the difference between the and the or here. And taking with the peanut butter and jelly scenario, like technically speaking, if I asked you for a PB or J, and you bring me a sandwich with peanut butter or ham, I mean, technically you did bring me peanut butter, and technically I should be okay with that. But anyway, that again, just some goofy examples to go with that. Now, let's kind of check some stuff out here. We're going to write a sentence as an inequality. I'm going to graph it. Well, here's actually the sentence. I said we're going to write a sentence. No, we're going to write the sentence. A number D is more than. All right, well, if you are struggling with your inequality symbols, remember I gave you this thing. Also, it's just available. But here we go. More than is going to be greater than. So let's zip up back here. A number D is more than 0 and less than 10. And if you're like, wait, what's this big blank thing here? And. So we're going to be graphing an and. So here we go. Let's do an open dot on 0. We're going to shade that way. We're going to shade the numbers that are bigger than 0, greater than 0. And then over here, all the numbers that are less than 10. Open dot on 10, we're going to shade this way. Now, I've intentionally gone through that dot and through this dot so that we can then decide, okay, what is the answer? It's going to be just this part. just the and, where they intersect, where they overlap, okay? So just this green one, and to clean it up, I'm going to graph it again. 0, 10, we have open, open, just in between. There you go. A number A is fewer than negative 6. Okay, fewer than, which would be fewer. Less than is fewer, okay? So number A is fewer than negative 6, or no less than negative 3. No less than, no less than, no less than, there it is. Greater than equal to is no less than. All right, no less than, greater than or equal to. And let's get to graphing. A is less than negative 6. Open dot, shade to the left. And then A is greater than or equal to negative 3. Closed dot, shade to the right, because that's all of the numbers that are greater than negative 3. And since this is an or, we're done. It's going to be this side. I don't want to say and, but it's both of those sides. It is either of them. It's the union. It's both. Okay? All right, I think you probably get it, but let's test yourself here. I think everyone was here for this in class, but if you weren't here for this class and you're thinking, well, I was kind of hoping to learn this stuff, pause for a second, try and fill these in. Okay, there's the pause, great. And an or, which of these is an and? Well, this appears to be an and, okay? And this one appears to be an or. In fact, how do I know that they just appear that way? Go backwards. This is what an and looks like, okay? This is what an or typically looks like. In fact, typically is the wording here. But anyway, let's keep going. Looks like we have a filled in dot on 2, and then all the numbers that are bigger. So x is going to be bigger than or equal to negative 2. And looks like we have a filled in dot on 4, and then all the numbers that are less than that. So x is less than or equal to 4. All right, sounds easy enough. Let's check out the next one. Filled in dot on negative 3 and all the numbers that are less than. So x is going to be less than or equal to negative 3. And then the other part is an open dot and all the numbers that are bigger. So x is going to be just greater than 2. We're done. Now, how do you solve one of these things if you were given like an algebraic inequality, you know? Well, check it out. Here is an and right there. I like to keep it the way it is, but some advice is you could also separate them into 2 of them. So right here we have them separated into 2, but here's what I'm about to do. I'm going to grab this and try it up here, just left alone. Okay, so let's do that. If I were to go up here, in fact here, I'm just going to leave them, I should leave them on the same screen so you can see them at the same time. This one, what I'm going to do is do the left one and do the right one. So here I'm going to add 2, and I get negative 2 is less than x. And then here I'm going to add 2, and I get x is less than 3. Easy enough. Up here, though, what I'm going to do is I'm going to add 2 to all 3 sides. And if you're like, wait, what 3 sides? Notice my lines here. I'm saying there's a central part, a left side, a right side. I'm adding 2, adding 2, adding 2. So I get negative 2, x, and 5. Well, guess what, guys? That is what this says. We just can't forget that there's an and there. All right? So now graphing this, we have an open dot on negative 2, and we are less than negative 2. We have an open dot on 3, and we are... Hold up. Did I mess up my symbols here? No, I didn't mess up my symbols. I messed up my shading. On this one, we have negative 2, and x is all of the numbers that are technically bigger than negative 2. So actually, this is a happy little mistake here because I don't prefer to have my variable on the right. I prefer to have my variable on the left. It just makes more sense to me when I'm graphing them because it just feels it reads better. X is all of the numbers that are bigger than negative 2. So let's go back and do that. Bigger than negative 2. There we go. And then let's go with the other one. X is less than 3, so we have an open dot shading this way. And oh, look, this is where they overlap. And since this is an and, that is our answer right there. Okay? And then just, by the way, again, that's kind of why I like to leave it like this, is because this just reads, hey, look, X is in between negative 2 and 5. Just like this picture shows, X is between negative 2 and 5. But you are free to choose and do this how you want. Next one, just another to practice. All right. So I'm going to do it right now. I'm going to leave it all as 1. And then in a second, I will do it. I will split them up. So I'm going to subtract 1, subtract 1. And I get negative 4 is less than negative 2x is less than or equal to 8. I'm going to divide by negative 2. And I get 2 and x and negative 4. And here's the thing. You know this. When we divide by this negative, we need to now flip the inequality symbols. And generally speaking, just like over here, when I said I like to rewrite these with the x on the left, the variable on the left, we usually write inequalities with the smaller number on the left. So notice how this got like flipped and twisted around, and now it's this, right? And if you're like, I'm having trouble, I really prefer it written where they're broken up. Cool, let's break them up. So there's the left one. Here's the right one, and now let's solve. So subtract 1. And same thing, subtract 1. Divide by negative 2. Divide by negative 2. Let's see. Did I do all that right? I think so. And then here's where it's my preference. I feel like that reads really easy. I feel like this, I have to think twice. Again, it's a preference thing, and my preference is to think less. So here I go doing negative 4 with a filled in dot. So negative 4 filled in dot. And then 2 with an open dot, and it's going to be filled in the middle. And if you're like, well, wait, why'd you only fill it in the middle? Because right here, I am told that I have an and. And so I really don't have to think about what it's going to look like. I mean, I suppose I really should, right? So, I mean, well, let's do that. Let's look at this one and be red. X is smaller than 2. Well, so it's going that way. We'll make this one blue right here. X is bigger than negative 4. It's going that way. And here's our overlap. So we just kind of quadruple checked that one. Next, we have an or. The thing with ors, you know what? Hang on. I remember in class there was one question about flipping the inequalities. So let me go through an example real quick of what we did. We said in class, we have negative 8x is greater than 16. And if we divide by negative 8, then yes, that flips the inequalities. So flip because we divided by negative 8, we did that, okay? But then what if we just had 8x? So here, I'll change the numbers so that you don't think it's the same. What if we had 7x is greater than negative 14? Okay, so we're going to divide by 7, divide by 7. X is just going to be greater than negative 2. That's it. We're done. No flip. Just because it involves a negative at all does not mean we flip. Only when we did the negativing, anyway, only when we do it does it actually flip. Okay, so that was just, we had a little discussion in class. There it is. Now let's go check this out. Add 5 to get 3y is less than negative 3. Divide by 3 to get y is less than negative 1. Add 1 to get 2y is greater than 6. Divide by 2 to get y is greater than 3. Let's get our graph on. open dot on -1, and we shade less than. And open dot on 3, and we shade greater than. And we're done, because it's literally an OR, and OR graphs look like this. Let's move on. Real life application. I told the story that when I'm driving in my car, sometimes the sun is baking into my car, even as I'm driving, and my phone, here's me in my car. Let's get some wheels. There we go. There's me. And down here is my phone, okay? So when the sun is baking me in my car, sometimes my phone overheats, even while I'm in my car. And it's kind of crazy. That's what this is talking about, by the way, if you're wondering why the heck am I talking about this. And then sometimes in the winter, if like you leave your car, I don't know, how would I communicate winter? We'll have like a snowflake. Here we go, snowflake. In the winter, if you leave your phone in your car, it will sometimes not work because it's too cold. And so that's what they're saying here is if we were to do it in Celsius, then between the temperatures of 0 and 35, we got frozen or we got overheating, okay? That's what F and O stand for. But we generally speak in terms of Fahrenheit. So here's what they're saying. This is Celsius. This is how you convert to Fahrenheit. And they're just saying, hey, could you figure out what exactly you would get? And now here we go. How are you going to solve this for Fahrenheit? Well, in class, you guys said multiply by 9/5. By the way, that is called the inverse of 9/5. You could also call it the reciprocal. Okay, lots of fun little vocabs. And what it looks like is that is also the same as dividing by 5/9. Because if you were to do 5/9 divided by 5/9, you always flip the second one and then multiply, and they would cancel each other. So lots of fun mathing that you could have done here, but it looks like in class we chose to multiply by 9/5, which I really like. So we multiply by 9/5 on all sides, right? What's going on? It is not liking how I'm writing right now. 9/5. So this cancels. This is just 0 is now less than or equal to F minus 32 is greater than or is less than or equal to 63, because 5 and 35 make 7. 7 times 9 is 63. Great. Add 32 to everything. And by everything, I mean on all three sides, right? And if you're like, I don't like doing that, I'd rather split it up. Split it up then. Remember, you have the freedom to do that. So the operating temperature range of your phone is 0 to 95 degrees Fahrenheit. So it asks, all right, if you left your car, or you've left your phone in the car when it's 150 out, you have an overheating phone. And that's no good, because you don't get to use it then. So there are the notes for compound inequalities. What I'm about to do is go and work some of the problems on here, and let me know what questions you got.